If we're given the concentration of a strong acid, how can we find specifically the proton concentration? In our first example, if we have 0.02 molar of hydrochloric acid, a strong acid, what is the proton concentration? We need to note that a strong acid completely dissociates into a hydrogen ion and an acid with a negative charge. So if we have 0.02 molar of HCl, that means we have 0.02 molar of H plus and Cl minus. So if we break this problem down, HCl 100% dissociates into H plus and Cl minus. Since we have 0.02 molar of HCl, we need to have 0.02 molar of each of its components. So our proton concentration will be 0.02 molar. Let's look at another example. If we have 0.015 molar of sulfuric acid, what is the proton concentration? Now here, if we were to show the dissociation equation, we would have H2SO4. It's a strong acid, so it will fully dissociate. However, each step can only dissociate with one hydrogen. So after this first step, we would have an H plus as well as an HSO4 minus. We have to have an additional step where we get another H plus and then we get our SO4 minus. So even though this is a strong acid and 100% dissociation will occur, it has to occur in two steps since we have two hydrogens. If we have 0.015 molar of our sulfuric acid, when we break it down, we're going to have two hydrogen ions per one sulfuric acid. So our concentration will need to be multiplied by 2 to account for both of those hydrogens. So our H plus concentration will be 0.03 molar, double of the sulfuric acid. Let's look at one more. If we have 3.5 times 10 to the negative 4 molar, so very low concentration of HNO3, what is the proton concentration? Again, we see we only have one hydrogen in this strong acid, so our dissociation equation is going to look like HNO3 dissociating into H plus and NO3 minus. This is only one step. For every one HNO3, we only have one hydrogen. So the proton concentration will be exactly the same. 3.5 times 10 to the negative 4 molar. What if we needed to find the OH minus concentration of a strong base? The strong base dissociation equation will be very similar to the strong acid dissociation equation, where we have a base with our hydroxide dissociating into our base with a plus charge, as well as our OH with the minus charge. So if we look at 0.125 molar of NaOH, that's going to dissociate into Na plus and OH minus. If we look for how many OHs or how many steps we had to take in order to fully dissociate to that 100%, it's only one step. So for every one NaOH, we have one OH. So 0.125 molar concentration of NaOH will give us an OH minus concentration of 0.125 molar. Let's look at the second problem. Here we have 0.04 molar of barium hydroxide. So if you see here, we have two hydroxides for every one barium hydroxide. So that means we need to double our concentration since we have double the OH minus concentration. So instead of having 0.04 molar, we have to multiply it by 2. and we get an OH minus concentration of 0.08 molar. Let's look at one more. If we have 6.8 times 10 to the negative third molar of potassium hydroxide, what is our hydroxide concentration? Now again, we look at how many OHs we have. We know it's a strong base, so it's going to dissociate 100% regardless. But we only have one OH per one KOH. So the molarity of OH minus is going to be the same as our molarity for KOH, which is 6.8 times 10 to the negative third molar. Thank you for watching.